Alright guys, welcome back to the Python tutorial series. Um, the last time we looked at the Python classes and we talked about to create a class and how to create an instance of that class. We also mentioned how we can use the instance of the class that we created to access the attributes in that class, and in the same way we can follow by using the instance of the class we created to access the methods that are inside the class, the functions that are inside the class. Like in this case, we have the sit and the rollover functions. Now today we shall continue in that and see how we can create multiple instances. We just follow the same pattern. We call the class name, which in this case is dog, and we pass in the required parameters into the class. So we name it a different variable name. Here we have my dog, your dog. And we can check that this is created by using the same variable name to be able to access either the attributes or the functions in that class. So here we're using the variable names to access the attribute age and age. And we're using to access the function sit inside the class. And we can see that printed out here. Now we continue with how we can work with classes and instances. Essentially, the idea behind this tutorial series is for us to be able to visualize a real world problem and see how we can code it in a software. So for instance, let's take a car and you want to model a real world class car. Then you need to be able to understand that there are certain attributes that are common to every car, and there are certain attributes you want to update, you want to change. And so how can you represent this in a software? So by creating a class car, we remember our required init method, which allows us to be able to pass in the required parameters for every type of car object that we want to create. So here we are using three parameters: the make, model, and the year. And our class car is having a method called getDescriptiveName name, because we want to be able to return a descriptive name of the car. So for instance, when you want to mention a car, you don't just mention the car by the make or by the year. You need to combine 3 or 4 attributes together to be able to get the descriptive name of the car. And so that is what this function getDescriptiveName is doing, just using the formatted string to be able to kind of concatenate all the attributes together. So we are accessing the self.year, the self.make, and the self.model. And then when we call this method, is returning to us a string, which is the long name. We're just using this title as a built-in function in Python to be able to have a title case format. So here we now create the car instance. So this is the instance. We're supplying the first argument make, which is Audi, the model, which is A4, and the year, which is 2019. So inside this reference variable, we have embedded all these make, model, year, and the descriptive name, and with these particular instances of Audi A4 2019. So when we use this reference name to be able to access the descriptive name, then it essentially print out the combination of all those things that we have defined here. So we can see that in a code here. So you see it in this place here, just what we have mentioned. So we have make, model, year, and we have defined it here, and we return the descriptive name, and we can run that. So we have our class, and we can give it the default value, and we can print that out. If we want to instantiate another one, so all we need to do to be able to instantiate another one is for us to be able to change, for instance, and say this is BMW, and they make. I'm not used to BMW. Let me say BM 250, and that's it. It's the year is 2020. So we give that to our car, and so I can turn this to my next car, and that gives my next car. And so once we run this, it just gives us 2020 BMW, and it is BM 250. So that's essentially what that is doing. Now, occasionally, when there's a demand for it, we might want to have a default value. That is an attribute that we don't want to pass when we're creating the init method. Anything we don't want to require when we're creating the object to pass in any parameter for that. We just want it to take a default value, and a good candidate for that example is odometer reading in manufacturing a car. Every car at newly made car must have an odometer reading of 0, so there's no need to pass 0 every time. So we just include that there and set it to 0, and we include a method inside the class car, so that when we need to read the odometer reading, we can just use the attribute name self.odometer reading to be able to read that. And that's what's happening here. And when you call my new car, and you can use the dot notation to access the read odometer, it gives us that the mileage is has 0 miles. But you can also set find a way of modifying the odometer reading, because we know for sure as the car is being used, the odometer reading will not remain at 0. So we need to have a way of accessing the odometer reading to modify that. And there are many ways of doing that. You can access the value directly. And what do? By doing that, you call my new car, and you access the odometer reading, which is our attribute that we have created here. So odometer reading, we can just access this and change these values directly. And so once we do that, you change this to 23. By the time you print the function read odometer reading, it returns 23. But another way is that you may want to modify that through a method, which is often the best way, and so that you can handle some logic before you modify it. So you allow a method to modify the odometer reading for you. So you create another method called update odometer reading, pass it and the mileage that you want to assign to the odometer reading, and that mileage will now be dumped into the odometer reading. So that when you call the update odometer reading, you're passing the mileage, and by the time you read the odometer reading again, that will give us 23. And you may want to do some logic on that. So you may want to add some logic into that to make sure that inside the update odometer reading, you check the mileage that has been passed, so that you will not accidentally set the mileage, roll back the mileage. So you want to make a logic and say, if the mileage you are passing, if it is greater than the current mileage, the current odometer reading, then allow the update. If not, deny the update and print a message to the user. So I want us to see that. So let's update now our class car, and let's update it with this. So we come in here inside our class car, and can have this here. So let's have that. So inside our class car, it took a while. Alright, so you see that, and if it is not, we have the else to do that. Just copy that, the else. So we come in here, do the house. So else. Yeah. Make sure this is aligned with this. Okay, so we have the update odometer reading, and we want to include that here as a default and say self dot odometer reading is equals to 0. So that gives a default value for that. So and we have the update, so anytime we want to update that, we just come in and we can see it passes through from this place. So for us to be able to actually see the odometer reading, we want to include a method read odometer, so that we'll be able to actually see that this has been modified accordingly. So this is the method read odometer, so we can have that method as well to show us what we need. So as read odometer, so let's format this one appropriately. Yeah, I think that's properly formatted now. So okay, yeah. So let's see if there's no error. Okay, so there's no error. So we can now create our new car as we have before. So we have our new car that we've created. So this is the class we instantiated, and now we want to update the odometer. So we can say use my new car, and we are saying it should update the odometer. So update the odometer, and it's requiring that we put a mileage. So let's say we want to put the mileage in our odometer as -4, and what do we see? So it tells us you can't roll back because what you already have in the default is 0, so we can't even have a negative odometer, odometer reading. And you might also, okay, let's update it appropriately. Let's say we update it to 100. Okay, now we have already updated it to 100. Let's say now we want to update it again, and we now want to update our odometer reading to 50. Now it's already 100. We now want to update it to 50. So it tells us no, because it's already 100. We can't update it we can't bring it back anymore. And if you want to see that, you may just print out the odometer reading by using the read odometer. So my new, then you just read odometer, and by the time you pass in that method, and it will print out what we expect. So this car has 100 miles. You can see that. So and if you want to update it again, and you just need to call that update, and you make it 200. So 200. So that has been updated to 200, and you print it again, and you want to see the odometer reading. You see that it is now 200 miles. Okay, so that is that. So that's how we modify the attribute value, by those two ways. So again, you can also increment the attribute value through a method. Incrementing means that instead of explicitly reassigning the value, you are adding to it. So you just need to have a method called increment, and instead of just saying assignment, then you just do a plus equals. Just like in this place, if I want to turn this one to increment, I will just say plus equals to. That means just add whatever it is to it. So if now my odometer reading is 200, by the time I call update again, instead of it to remain 200, now digital reading will have been added up to, then it will now become 400, because that is just doing an addition. So you see, something is wrong there. Oh, okay, I need to rerun this class. I need to reinstall shader. So let's see that. So this is 200. You can roll back and read. This is 100. Then update, it becomes 200. Read, it is 200. It's add now. Can you now see? It's because I've now, it was 100 before, and when I now updated, it becomes 200 plus 100, giving me 300. If I update it again, then it becomes 500. Okay, it can't even do that because it's already below, because this is 200 and you already have it as 300, so you can't bring it back. So based on that logic, so it is still 300, but let's say I want to update it and I'm adding like 500 to it, then it will become 800. So that's just what that is doing there. So just a way of incrementing, and now to get rid of the assignment that we did before. Okay. So next time we shall be looking at how we can actually inherit in Python. Thank you for listening. Do let us know how you benefit from this. Do give it a like if you benefited, and see you in the next one.